Hello, and welcome to Urbit Developer Call. I'm Josh, we're Podlex, and I'm here today to do a talk with Liam, who's an engineer at Tlon, who's going to talk about user space networking. Before we get into that, just a couple things to know. One is that in about 2 weeks, we're not going to be doing a developer call. We're going to be doing our first town hall event, which is where we're going to have a little introduction from me, a couple of talks, one from our friend Hunter, who has done everyone knows him as the guy who's written Taisho. He's going to give a talk about that. We're going to hear from Justin Murphy, who's going to give a little keynote talk on exit. And then we're going to have a series of community-led talks for about an hour and a half, each about 30 minutes long, kind of brief and impromptu. Definitely stay tuned. We'll have more updates about that coming up out on the Urbit website and over Meetup and Twitter, all the usual channels soon. So if you're not familiar with it, the format of developer calls is that we're going to have Liam on. We'll talk briefly. He'll give a presentation. There will be some time for Q&A at the end. And then we will open up a Google Meet link where you can join in and talk to Liam and myself and whoever else is here and wants to hang out and just talk about Urbit and whatever. So with that, I'm going to go ahead and bring on Liam. Hey, Liam.
Hey.
How's it going?
Yeah, not too bad.
Good to hear. So you are an engineer at Tlon.
Yes.
What are you working on? Just to give some background.
What's my background? I dropped out of university first year. I went to work at a startup, and then I left that startup, and I came to work here. That's basically my whole background. I mainly do like bit of back end, bit of front end, kind of, I guess, full stack. The weirdest.
You're kind of all over the place with the landscape, all over the stack. Any fun facts about Liam that we should know about?
Something before. No.
We can. I don't have to put you on the spot. We can save it for later. Yeah. Should we? Okay. So you're going to talk today about user space networking.
Yes.
Yeah. Okay. What do you mean by that?
So basically, we have this idea of this idea of like a store, which is basically like a database in some sense. It's defined as an ODAT. And so, we have this store. And so the next question is, well, how do we replicate the database to somewhere else? So we basically we define your chats as a series of messages. How do we get those chat messages into everybody's database so that you can read them? And that's basically how do we replicate this data across the network?
Mm-hmm. Yeah, and there are some challenges with that. So I hear, which is kind of the whole purpose of this talk.
Yeah. So the API is a bit interesting, but I come from a long line of JavaScript developers who will do whatever they can with the APIs that they have. So
that's right. All right. Well, let's get into the talk and learn a little bit about user space networking, and we can come back afterwards. Feel free to ask questions throughout the talk. They won't get answered.
The accent is going. Just answer that Gus question.
Yeah.
The accent is going.
Yeah. So continue.
Yeah, which is why the talk is at 4 5 p.m. American time or whatever it is there.
Yeah, and it's Friday for you. Yeah. I'm very happy that we could do this at this time because Gus is also in Australia, and this is the first developer call he's been able to see live. So we're looking forward to seeing you in the meet afterwards, guys. All right, let's talk about user-space networking. I'm going to drop off. Liam, take it away.
So basically, we have this thing in landscape called, like I said earlier, the store hook model of like, we have these databases that we like define as like over apps, and so the question remains, like, how do we, replicate these databases so that, like, when you join a chat, you're not just like receiving updates from the host. You're actually like storing those updates in your like like a local copy of that database on your Urbit. So like, and that means that like it is in some sense yours, because you own a copy of like all the chats that you're involved in. You can do whatever you like with them. And so the way we do this is with subscriptions. So a subscription is an asynchronous request for one or more pieces of data. What that means in practice is that you say something along the lines of, hey, I'd like, all new chat messages for this particular chat. And so a subscription is specified as a path, which is like a list of strings. So it looks like, for example, like the general chat in Urbit communities /graph/Derek Slanders /general. So give me all the updates to general. And so this little diagram at the bottom here, it's basically like the life cycle of the subscription. So you can see the subscriber, it sends a request for a subscription, which is called a watch. That subscription then is acknowledged with a watch act, which can either fail or like succeed. And if it succeeds, then we will get these pieces of data called facts. Like we can get one, we can get as many as we like. And then what will happen often with subscriptions is that a kick will be sent, and kicks are generally sent due to network pressure. So if you haven't responded to, like, if the like kicks haven't been acknowledged, we basically end the subscription and we send another one because we're trying to like basically reestablish the connection. And so this basically happens. And so on a kick, you generally just want to like immediately rewatch whatever you were listening to. And then, and this cycle just continues over and over and over again ad nauseum. And so a fact is basically a piece of data that comes over the subscription, which is a mark, and then the data that represents that, like the data for that mark. A mark, never mind. A mark is basically Urbit's equivalent of a JSON schema. It basically defines like, how do we validate this data type? So you might define like for example, like a chat update, and you say, okay, this is an update to a chat. This is how we validate it when it comes over the network. And so everything that, like, all the pieces of data that come across the network have to have a mark, so that they're not like we're not blindly trusting like untrusted data. And so, these pieces of data that come over, they have marks, and then they have the data for that mark. So the issue is networking logic is difficult. For one, there's many reasons you can get a kick. So if the publisher breaches, the subscription is kicked. If the mark validation fails, the subscription is kicked. If you have too much network pressure, the subscription's kicked. If the publisher like manually ends the subscription, then it's also kicked. And so this like makes like some of the logic difficult, because it means you can't do things like subscribe to two different paths, like one for the current updates and then one for the backlog you missed on the kick, because you like the backlog subscription might get kicked and you won't know that you've gotten all the backlog. Yeah, the ordering of facts is only guaranteed on a like per path basis, which means that yeah, again, you can't do this two subscriptions thing. You need to be careful about what like paths you have available to subscribe on, because again, because the ordering is guaranteed, if you have like if you're subscribed to two chats and somebody sends a huge message in one chat, you don't want that to hold up the like receiving and sending of messages in another chat. And so when we kick a subscription, we have to like encode information like into the path, so that when you resubscribe, the publisher doesn't have to send like the entire state of the thing. So for GraphStore, which is what chat is built on, we time log all the updates, and the subscriber sends the time of the last update it heard. So yeah, this is the example path for the general chat and Urbit community. And yeah, we pass out that date, and then we give all the updates we give all the updates since that point in time. And so this like encoding, I don't know if you can see my mouse. This path encoding can get kind of tricky, depending on like how much information you have to encode into the path. And so if we rewind to I think like early 2020, we used to have like a lot of hooks. We used to like re-implement this logic literally everywhere. And it sucked because we had to like deal with these foot guns like again and again and again, like 3 or 4 or 5 times, I think it was. And so the solution to this was the hook libraries. Anybody can use these to like network a store. So if you're like, writing your own Gall agent, you're absolutely welcome to hook into these and use them to like network your stuff. It does require that like your store state is like a map of resources to whatever the store like state is. So like for example, for GraphStore, it's a map of resources to Graph. And so for contacts, it's a map of like resources to contacts, so on and so forth. A resource is just a pair of the ship, which is the host, and a name. So it's basically like, I guess, opaque identifier for, I guess, anything on Urbit. So how do we handle kicks with the pull hook libraries, with the like hook libraries? So pull hook defines an arm called onPullKick, which encodes how much of the backlog that we already have, and pushhook defines initial watch, which decodes this backlog information and then returns the necessary data. And so there's this bijection between these two arms that allows them to coordinate and not send everything initially. So ordering of updates. Each update belongs to one or more resources. Typically, each update belongs to one resource. We only use the one or more case for contact store, which is a bit of an odd case. It's not super typical. Each resource is guaranteed to see the updates in the order that they came from the store. So all your like, that's a solve for you essentially. The ordering problems and stuff like that. Both of the hooks define an arm called resource for update, which gives you this mapping from update to resources. Yeah, and so once we have like defined these things, we have basically like a viable networking implementation in under 200 lines of Hoon in some cases. So group push and pull hook, which is the networking for the group store. It's less than 200 lines for both the push and the pull hook collectively. And so this is, I guess, how it works. The push hook hears updates from the store, and then the pull hook is subscribed to those updates, and it forwards those updates to its own store. Pretty easy to wrap your head around, like conceptually. And so we have more issues now because when we OTA'd the new contacts model, where everybody has like one contact and they're not scoped to groups, we had some problems in deployment because there's this infinite KickFree subloop. And if you see this diagram here, is basically what was happening is that the subscriber sends a watch, it gets a watch act back, it receives the backlog of the update, but the fact validation fails. So like because the types are different, and that's essentially treated as a kick. And so it resubscribes, it gets kicked again, so on and so forth, and this just happens until the whoever is behind receives the OTA, and once whoever's behind has received the OTA, then we then it's fine. But you can't receive the OTA because you're getting too many subscription requests because they're constantly being kicked and resubscribed all the time. And so infrastructure came down and said, you need to implement subscription versionings. And so I was like, oh, well, what does that mean? So the solution to subscription versioning was to freeze the marks. So once we deploy a mark definition to mainnet, we never upgrade it. And so now our mark definition, our mark validation will never fail if we have the mark. But what happens if the publisher and the subscriber are out of sync? How do we negotiate that? So there's 4 cases to think about for version negotiation. So either the publisher or the subscriber is ahead, and the versions can be compatible or incompatible. Subscriber sends the version of the mark that it wants. So we now have a slightly more complex path that says, hey, give me version 1 updates to the general chat from this date. And so when the publisher, so we have this automatic conversion where Clay allows us to define conversions between marks. This is used for things like when Landscape, the web client, listens to updates, they automatically get converted to JSON before being sent down, because JavaScript does not really understand nouns well. And so Clay allows us to do this. And so we define these conversions between marks, and the push and the pull hook libraries will convert between them automatically if you declare the marks as compatible. So the neat thing about this is that the number of conversions to be written is actually there's n conversions to it, because Clay can generate a conversion from 1 to 3 by composing 1 to 2 and 2 to 3, and so on and so forth. So you can imagine if you have 1 to 6, you only need to write 5 conversions, which is nice. And so that's the conversions. If they're incompatible, if the publisher can't serve the requested version, then we send the minimum required version. So and we end the subscription. So if we look at this, the top one here, the subscriber is ahead here. It sends a watch. The publisher's like, oh, I don't know what version 2 means. Wait for version, like, I'm on version 2, please wait for it. And then, when the publisher upgrades, the subscriber will hear that, the publisher is now on version 2. And then the subscriber will be like, okay, sweet, the versions now match up. It'll send the watch and the subscription's restored. And so if the publisher is ahead, if the publisher is ahead, then same similar thing. Oh, I want to watch for version 1. Publisher says, oh, I can't do that. You're going to have to wait till you hear version 2. The subscriber upgrades, it sends a watch, and everything continues. If it's compatible, then the publisher just converts it automatically, and you really don't have to worry about anything. Negotiation. Yeah. So if the publisher or the subscriber changes versions, we renegotiate all their subscriptions to ensure that we're still compatible. So if the subscriber upgrades, it needs to recheck that all the subscriptions are good and are still compatible with everything. That's basically it. Questions?
Cool. Thank you, Liam. All right, so questions. If you have your questions, go ahead and throw them in there. In the meantime, I have one immediately from just about the push and pull hook. What is the idea behind push and pull? Can you explain the naming real quick?
Naming? Well, it's because the push hook is supposed to push out the updates, and then the pull hook receives them, gathers them in one place, and forwards them on.
Okay.
You could also name them send hook and receive hook.
But push and pull is what kind of stuck.
Push and pull. It's nice and symmetrical. It's 4 letters.
Yeah, but it is 4 letters. That's important.
The pub/sub helper functions defined, such as watch, get translated to the underlying network components packets. That's a good question. This is basically, so we have Ghoul, which is the app, the agent, the agent thing that does basically provides, allows you to develop in user space, defines the app model for Urbit. And so that sends basically that they all get converted to AIMS packets. I'm not overly familiar with the specific mapping of how an AIMS those watch get the subscriptions and stuff get converted, but that's probably more of a question for infrastructure. I'm not overly sure. Our version mark.
Got another one here.
Yeah, I can use in my own Ghoul agent without push and pull hooks. Yeah, so we have this versioning door. It's in lib versioning. And you basically have to give it some information about you've got to give it a bowl, you've got to give it a minimum version, the current version, and then you can just use the convert to and convert from doors, arms in that door to just automatically negotiate everything. But you just throw a number on the end of the mark, and then you're happy with it.
And that's basically the idea, right? Is you just, to version a mark, you just stick a number on the end of it, and when you add a new mark, you increment the number a while and then leave the other one there. And so you just don't break backwards compatibility by leaving old marks in place. Yeah. Could you talk a little bit as well about like the general backwards compatibility story? Does this, to what degree does this solve the compatibility issue with API changes over time?
Yeah. So I guess the story around like backwards compatibility, it's interesting because like Landscape is starting to accrue more clients than just, well, like Urbit is starting to accrue more clients than just Landscape, the web browser. And so, yeah, it was like an iOS app. We are probably going to have to like slow the API because we can't like change it whenever the hell we feel like it. And so the solution to backwards compatibility is obviously not to make breaking changes. So don't declare, like, just stop declaring things as incompatible, and just ensure that there's a conversion for everything. And so, yeah, that, like, in theory, that's like the solution. And then yeah, basically.
just only add code.
Yeah, only add code.
Yeah. There's a Rich Hickey talk called Speculation that he gives, where he's talking about how to solve the breaking API problem, and he just says, just never remove anything. Just always add new API every time you need to do it. It's easy. Just stick a number at the end of your new function instead of changing the old one. And like, it looks terrible, but you'll never break the API then. Just always introduce new stuff, which is generally very offensive to a developer's sensibilities, because you don't want your code to look like a big growing mass of numbered stuff. But that does work.
Yeah, no, it's I mean, yeah, like that long-term support of like old versions that you don't want to think about is going to be kind of painful. But I think like there are ways in which we can like ease that pressure. Like you can imagine relegating, like, yeah. So is it possible to use version marks but still break backward compatibility? Yes. Yeah. So that's the incompatible case that I talked about, where you basically like stop the subscription, you wait for like the publisher and the subscriber to become in sync, and then it resumes once they're back in sync. And so I guess, does that answer your question?
Yeah, we'll assume it does. There's about a 7 to 10 second delay on this, so I'll tell it shortly. Here's another question from Jake. Yeah.
If I can redo any user space component, what would you choose? My biggest regret is probably appending, like, prefixing ship to the like path conversion functions for resource, because it just makes everything slightly more janky. The original like idea for resource was that you could like, you didn't have to specify just a ship, you could specify like other things, but that never got implemented. And then it never got implemented, and and so now we just have this unnecessary ship qualifier like cluttering up our paths basically everywhere, and it sucks. I hate it. I think about it every time I like read it. I'm like, why did I do this?
Yeah. Sometimes we just have to live with those things.
Yeah, I don't know if that qualifies as a component. Yeah, I know. I feel like group store is probably the oldest like component that is like reasonably complex right now. So I guess that if you're a whole agent, but I don't know.
Mm-hmm. So speaking of redoing things, something that has been talked about for a little while at Tlon, more and more lately, is this concept of subscription reform. Can you tell us a little bit more about subscription reform, and then we'll come back to Jake real quick.
So I guess subscription reform is this idea of like, how do we make the like push and pull hooks like unnecessary? Like you shouldn't have to like write all this weird kick handling logic and so on and so forth.
Yes, the idea here is like, when you subscribe, you shouldn't just be getting kicked randomly. Like that feels kind of janky.
And so we have to send these kicks because like AIMS basically has to store every packet it hasn't received an ACK for. And so basically if we stored every packet and we just continually like send stuff and we weren't receiving ACKs for those packets, then the loom would just blow up. So you just run out of memory pretty quickly. And so, in order to stop that, the subscription just dies, which is annoying, but it prevents things from blowing up in more annoying ways. So that's nice. But basically, the subscription reform is this idea of like, how do we, I guess, like remove the idea of kicks without having to without having to, I guess, necessarily blow up the loom or like have any of these like nasty side effects. And there've been some ideas floated. The one I'm partial to is defining, I guess, data types, like defining a store in Clay and then using like Clay diffs and synchronize, using basically like Clay's native synchronization algorithms to use that. But yeah, I guess it's been talked about for a while.
Yeah, there's a number of people that are all kind of talking about different approaches to fixing this. It's still in sort of active R&D mode. Whenever the solution does come, I believe that means that there will be breaking changes most likely to Gall itself.
Yeah,
right?
Absolutely. I don't think you can bolt them on without breaking the API.
Yeah. That probably has a lot of implications. Like how do you think we tackle that? Because I don't think there have really been any actual changes to Gall, which is what most of user space programming goes into, since before we really had anything significant built out in user space that a lot of people used. That seems like it'll be a lot of work just for landscape, but it'll be important to interface with the community on that too, I would think.
Yeah, absolutely. I mean, I can imagine that we would potentially support both like models of Gall for some time before maybe dropping all the, but that's an infrastructure question. I'm not overly familiar with that. I would definitely be opposed to just being like doing the what we used to do, which is basically make a cross-cutting commit where we update everything and then move on.
Let me say, sorry guys. Here's the docs. Yeah. Well, we'll need to not do that this time. We'll have to think about it a little more deeply. Cool. All right, let's talk about answer Jake's most recent question. Could you go into a bit more detail about how you wrote the push and pull hook libraries? Do you think that design can be used elsewhere?
I think so. The design, I guess, as in the design as in like the idea of using basically like a wrapper core to like add arms to like a Gall agent is used in Mark's shoe. So Pauphon Foslop wrote a lib shoe which does basically very similar things. Very similar things for chat like CLI apps. So you basically just a bunch of convenient stuff so that you don't necessarily have to deal with like the specifics of the DIL API, which is a bit arcane at this point. And so I think that I like extracting things out into like a wrapper where you can yeah, extracting things out into a wrapper where you can, I guess, like deal with stuff like that is, it's not overly difficult, but I think you definitely need to know where like the points of, I guess, abstraction and like what exactly you need to be polymorphic over in order to like do it. I think like the design can definitely be like used elsewhere. It's useful for basically any kind of like similar but different like similar in some sense but different in other. I guess it's kind of in like almost like defining, I guess, like an interface for a data type where you like, yeah, if you define an interface for a data type and then you can just define that interface for like a bunch of data types. Yeah, and so on and so forth.
Fair enough. All right, we got questions coming in.
Yeah.
Oh, here's a fun one. Are we going public?
I don't know. It's a you question.
Yeah, I mean, you know, go buy a star from someone. Trade it now. Okay, so how would the approach to subscription reform, KlaiDiffs, work for inherently event-typed data like STP messages for Switchboard? Referring back to your idea around music play.
For inherently event-type data, that is a good question, and the answer is I'm not sure. And so that's obviously why like KlaiDiffs haven't been done like now. Obviously, there's still like large amounts of like unsolved questions around like I think it was Ted Rothermere made a interesting comment somewhere in a PR that I will have to dig up later. That basically outlines this concept of like called it like I can't remember what he called it. Basically, there's two kinds of subscriptions. One where you want the diff and you're like actively reducing a state, and one where you're not and you really only care about like the latest thing. And like, you know, if you get kicked, you might want to send the exact same thing on every kick, or you don't care about the stuff that you missed during the kick. Yeah.
Okay. Got it. Looks like Phil is in the audience, but anything to add about opera/opus?
Yeah.
Maybe Phil will be around afterwards to talk about this.
Yeah.
Yeah. Good names. Is computational demand placed on the publisher if they're sending packets as the version requested by the subscriber? It seems like that should fall on the subscriber.
It is, but only if like the subscriber isn't able to like to do it. So yeah, the long and short of it is that if the publisher knows about like version 2 and the subscriber only knows about version 1, then the publisher has to be the one to downconvert that fact, because the subscriber hasn't learned about V2 yet, so it can't obviously do the conversion. But yeah, in some cases where the subscriber is ahead, if it knows about V1, if it wants V2, it will do the conversion on its side.
Got it. Okay. Well, I'm not seeing too many more questions. I know, you know, one other thing that I've been having a couple conversations with various folks about lately. You know, there's this, I guess, a lot of the work that's been done in userspace, that a lot of what you've been doing is all to stress test Gall and figure out just how well it performs under load. And we're finding usually pretty good, but there are some glaring problems. And the push and pull hooks, as we've discussed, is kind of one of those ways to get around some of those issues. There are other issues as well that have been talked about kind of within AIMS. I know Logan has been thinking about some of this as well. Any other scaling issues you can speak of or speak to that we're looking into?
Yeah, I mean, probably one of the biggest issues right now, performance-wise, is just like scries and stuff like that are really slow. And so, yeah.
Why is that?
Basically because a scry is kind of like performance-wise, it like obviously a scry returns a vase and that gets like implicitly devased by the .get rune, but like you're still vasing and devasing, which can be a really expensive operation depending
What
on
is vasing and devasing?
So a vase is basically like data.dynamic in Haskell or like something like that. It's basically just like a generic piece of data and you can unwrap it.
Yeah, it's kind of like a way of sneaking dynamic types into a statically typed language.
Yeah, absolutely. So yeah, you can like vase something, which is to like turn it into a vase, which and then to devase it, you just you give it the type that the vase is supposed to be, and it turns it into that type.
And that's a computationally expensive thing.
Yeah, it's expensive because you have to basically, if the types don't line up exactly, you've got to do like checks. You got to like walk the entire like noun, which can be really large. So like for often we like so for example in like Hark, we scry out conversion gates to convert like a chat message into a potential notification. And those are really expensive because we scry out a function that takes a vase and returns a vase, and then we have to, base the chat message to put it into the like conversion function, and then we have to devase the result of it to get the possible notification.
Yeah.
So yeah, that kind of not great. But,
so how do you improve the performance of that?
Not really sure. I've seen some like proposals, ideas for it, but I think the idea for improving the performance of that kind of stuff is just to do less of it. It seems like the easiest way to do things. So like instead of like scrying out that gate, we just keep it in a cache, and then like we only repopulate it when it changes. Doing stuff like that, I guess, to make it faster, and then. Yeah, that's I guess we can the most we can do from like the user space side of things.
Okay, I see.
Yeah, or cache that's tricky.
Yeah. Actually, this is another question. Looks like I missed it earlier because I didn't see a question mark. But yeah, how could you write an app such that someone could easily extend it without changing the base app?
This is a good question. How could you do that? I guess. Well, the way I guess you could do it is to basically. Well, I mean, you can imagine writing like an input transformer of some kind, I guess. That like basically, on poke, does something before the like inner agent like hears about it, something like that. You could, I guess, you can do something like that. Like basically, like hook into the like original state. Define a map of cores where the cores are all also like goal doors. Fuck, that's weird. Define like a map of some like a term to like a door, and then you compose the doors, and then basically before the inside like agent hears about it, it's got to run through all the like outer stuff. So I mean that could be one way, but like it kind of limits what you could do with it. it's a good. One of the things about Urbit is that I guess you often want to see what it looks like in practice before you actually go and do it. And so like yeah, I don't know. It's like if somebody has a good idea for like one of these plugins, then like I'd love to like help write it, because like yeah, I don't think you can really speculate on the plugin system until you've like actually got like a good use case for it. Kind of how you want it to work, I guess.
Yeah, that's right. All right. Well, I think that's it for questions. So, is it time for a fun fact?
Yeah. Well, so basically, the running joke is, I have a magnet installed in my finger, and yeah, I guess that's the demo you maybe want.
Yeah, that's the demo. So I guess it's not really a joke because it's real.
No, it's not really a joke.
So, what's the deal with that?
Basically like physics, like a moving like electric current will cause a like moving magnetic field, and so you can basically like feel like electricity in some sense. Like 50-60 hertz AC is pretty distinguishable to me.
That's awesome.
Yeah, that's pretty neat.
Very cool. Well, I think now's probably a good time while we get everyone here, to jump in and just hang out and talk about magnets and electric currents and user space networking. So if you would like to come in and ask some questions, or just hang out and talk about whatever, here is a Google Meet link that we are going to jump into and hang around for however long, 30 minutes or so, a little longer, we'll see. So I guess thanks everyone. Thanks Liam for coming on and telling us about this. And thanks everyone for showing up. We'll see you, I guess, in 2 weeks for the town hall, which will be at noon Pacific, going into the early morning hours for you Australians. Well, yeah, we'll see you there.